x in its domain, the number negative x is also in the domain. And f negative x equals f of x. That's a bit of a mouthful, so let's just look at a table and see what that means. A negative 1, 2 on there. That's what this, the opposite of x still gives you f of x. So this is the original y. So a negative 2 would give you 6, and a negative 3 would give you 14. Hopefully that reminds you of something. Hopefully you're thinking, well, that is y-axis symmetry, and that would be correct. So an even function has y-axis symmetry, and a function that we're pretty familiar with that would have y-axis symmetry would look like this. Sorry, I'm a little bit of an angle there, which would be x squared. Okay? A function is odd if for every number x in its domain, the number negative x is also in the domain, and f negative x is the opposite of f of x. Well, that means the following, and that means if you plug in 1 and you get 2, then when you plug in a negative 1, so that's that negative x, you should get a negative 2, the opposite of what you got the first time. So at a negative 2 you would get a negative 6, at a negative 3 you would get a negative 14. Excuse me. So for an odd function, for every point xy on the graph, the point a negative x, negative y is also on the graph. Hopefully that reminds you of origin symmetry. And I'm going to pick a different function for origin symmetry than I usually do, or that I did last time. So this function has origin symmetry. Right, that is 1 over x, a hyperbolic. Okay? Alright. Next definition, theorem. A function is even if and only if its graph is symmetric with respect to the y-axis. We just discussed that. And a function is odd if and only if its graph is symmetric with respect to the origin. So that follows out of those definitions. So even function, y-axis symmetry, odd function, origin symmetry. Odd and O go together. Right, determining even and odd functions from the graph. Alright, see if it's even or odd. Well, this graph is a flipped quadratic, so it has y-axis symmetry, right? And we just said if it has y-axis symmetry, it's even. This graph does not have y-axis symmetry, and it also doesn't have origin symmetry, because this point, for example, would be mirrored here. So this is neither even or odd. So that's sort of weird maybe, right? Numbers are even or odd, sort of. 0 is not, but okay. But functions, you can have even functions, you can have odd functions, and then there are functions that are neither. And then here we get origin symmetry. You see these points are mirrored through the origin. So this is origin symmetry. So this would be the graph of an odd function. If you're asked to determine or identify even and odd functions, and you're given a function, then you have to basically do what we did in the previous section. So for even, we're going to plug in a negative xy, and then for odd, we're going to plug in a negative x, negative y, based on the fact that these functions have symmetry. So I'm going to be a little lazy, so I don't have to keep writing that. And hopefully I gave myself enough room. So even here, so replace this with a y. So we're going to plug in a negative x. There's a negative there. And a negative x here. So we get y equals a negative x cubed is still a negative. And then this negative and that negative cancel. So that's not what we started with. So it's not even. If I do odd, then I get a negative y here, and then 2 times a negative x cubed minus a negative x. Okay, I'm going to borrow a little bit from up there, so the right side is a negative 2x cubed plus x, and the left side you just get this, but then you want to get rid of this negative, so change all the signs, so whatever is negative becomes positive, so negative becomes positive, and positive becomes negative, and you see you're back with the original function, so this is an odd function. Okay, I'm going to do another cube and hopefully you'll see here in a second why. So same thing. So still no symmetry here, so it's not even. And then if you plug in a negative y, you get a negative y is a negative 5x cubed minus 1. And then we change all the signs, so that's a positive. This becomes a positive, but so does this. And that plus 1 does not match up with the negative 1. So this is also not an odd function. So the reason I did this cube here again is to make sure that you understand that not all cubes are odd functions. And that's a little weird because cube is certainly an odd number, right? Just like squares, x squareds are often even, depending on the format of it, but they don't have to be. So don't just assume things, plug stuff in, work your way through the problem and see what happens. Alright, what are we doing here? Increasing and decreasing or constant. So increasing means the graph goes up, right? That should ring a bell. So this graph goes up, starting at a negative 4, up to 0, 4. Now when you write the intervals in which a function is increasing, so we only use the x values. Okay, only x values. So the first x that I use is a negative 4, and then it's increasing until x of 0. So that would be how you answer that. These will always have open brackets, and it will be easier to explain here in a second. Okay? So where's the function decreasing? Well, decreasing means the graph goes down. So from a negative 6, from x negative 6 to x negative 4. So negative 6, negative 4. And now I can explain why you have to use open brackets. So open bracket means that the number is not included. So if you had used square brackets there, trying to indicate that at a negative 4, so including a negative 4, and then here also negative 6, and I probably should have had this square then, negative 4, you would be telling me that at a negative 4 the function is both increasing and decreasing, and you can't be both at the same time. So you use open brackets when you do these, okay? I'm not done with decreasing because it decreases, then it increases, and then apparently it's constant, so there's another answer there, but then the function is decreasing again starting at 3 all the way to x is 6. And then constant from 0 to 3. So the formal definition for increasing, decreasing, and constant is below. Okay, so a function is increasing on an open interval I. Again, they're doing this with open intervals. For any choice of x1 and x2 in I, with x1 less than x2, we have f of x1 is less than f of x2. It just means the following. If you're looking at a graph, and you pick an x1 here, and then a bigger x2, this function is decreasing if this y value, there's our y values, right, is less than that y value. And if that is true for every x1 and x2, every pairing you pick, as long as the first x is smaller than the second x. And then you have the same sort of reasoning for decreasing. Okay, so it's decreasing if the first x has a larger f of x. So if this y is larger than that y, then on this part of the graph we're decreasing, and constant would be when the two y values, are the same. And you sort of know this, but I wanted you to see the open interval definition here. And every now and then it's good to read some math that's a little bit more tedious, which, yeah, this falls in there. And that's it. So I guess we'll do mins and max next time. Thank you.